So we just did a whole bunch of R&D tech that you can't have right now. So we thought we should follow it up with a bunch of tech that you do have and probably don't know you can do this stuff with it. So next up, I'd like to invite Duncan Brinsmead, who's going to take us through some of the tech you've got in your hands and just didn't know you could do things.
Hey, everybody. It's great to be in Anaheim. We just start up Maya. I love how fast Maya starts up on my MacBook Retina. And yeah, this is the first time I've done a SIGGRAPH demo where I've actually started up Maya at the beginning of it. Okay, and I go to my first file. Okay, so actually Anaheim was my very first SIGGRAPH back in 1987. So it's kind of extra special for me to be here today. And before I start, I just want to say, too, that right now I'm working on one of the largest and possibly the smartest development teams I've ever worked on before. And it's been really challenging. And I find myself feeling kind of dumb a lot of the time, you know. But feeling dumb is good, you know. So, but what I'm going to show you now is some stuff from that I'd worked on in my 2014. First off, with NHair, we added the ability to do hair on cloth and have it interact in a two-way fashion, like if you have a fur coat or something, right? And so I'm not going to show fur coats, but it's kind of fun. I had this little koosh ball thing I did, and it's using a little bit of the stickiness on the thing so I can kind of interact and play with it. And sometimes it gets sticky like a darn piece of gum, and you try and shake it off. And okay, so now I'll just play with this little koosh ball a little more, and you can see the kind of stickiness and trying to shake it off and see if I can get it shaken off. Maybe if I roll it on the ground here, I'll shake it off. There you go. Okay, on to the next thing. So also with NHair, we added the ability to have animating input rest curves for the hair. And that works really well with NHair with the collisions on it. So I did some snakes, and just by having the rest curves wriggle, it makes the snakes go forward like a muscle, sort of, and use a little just a little bit of anisotropic drag on it, and we can kind of interact with these guys. So I could lift this wall and try and let some of the snakes go through and catch them under it a little bit. So it's not very pleasant, I suppose, but no snakes are harmed in this. Okay, and another thing we added now, I'm going to go into the paint effects features now. So we added a lot of stuff to make paint effects aware of surfaces. And so the most basic of those is collision. So I can select the object in the hair, and you can go in and under paint effects, we now have this make collide. And if you do that, then your object, when you move it, when you move your object, it'll then collide with your paint effects. And nothing more to do, and it collides with the full mesh. Now, if you're using these surface effects, I'd say get to Surface Pack 1 because it runs way faster, in some cases 100 times faster if you've got complex meshes and stuff, not just with the collisions, but with all the other stuff I'm going to show you with this. So here's a head model, and I'm going to paint on it, let's say some stubble with just a simple stubble brush. I'll kind of resize that. And now you see a typical kind of problem here, if you've been using paint effects, is it only knows about the stroke and not about the rest of the surface. So it knows about the surface at the point. Well, now we can go into the brush here, and under Tubes, Creation, there's an option for Surface Snap. And so now if you select that, it'll be on, and you can go in and change the brush width and stuff, and it'll just go over the surface as you do it. So you don't need to do millions of little strokes and stuff. This is also useful if I'm painting, say, trees. So let's say I've got this train here and I paint some trees on it. Now I want to have more like a full forest. You might just want to increase the width of your brush, say to 8 here, and then maybe add a few more trees by increasing the tubes per step. But then, if we step back here, you'll see a bit of a problem. Some of the trees appear to be off in air and all over the place because they're all tangent to the normal at where you painted and not actually on the surface. So again, just go in and use your handy dandy surface snap, and it's all right back on. So another thing we can do, and this starts getting a little more interesting. I'll take a vein brush here, and not only are we surface aware, we can collide with the surface, but also, if I'm painting this stroke, it can try and fill the surface. So we have a bunch of points, and this is the occupation features now on the brush, the surface occupation, and so not only is it being attracted to the surface and colliding with the surface, but it is trying to put the branching as best it can where there's no other branches, and also when it gets too crowded, the branches die out and get pruned off. So you've got a lot of nice controls for shaping that kind of stuff. Here's just one brush. I just painted the back of the head there, and I could select the brush and then just go in and under the occupation attributes, which are under behavior, occupation surface, we've got things for occupy attract, so I could lower the occupy attract and it'll push back. And the leaf density too, because of the branch pruning, will stay fairly constant on it, so that you can get an even density of leaves without overlapping on effects like that. Okay, here's another example. I've got a little tree and or a little rose bush, and I want it to grow on this, so I can select it, and it already has some occupy attract on the brush, so I'll just do make collide, and it will then try and kind of fill with this object, and I can move the object, interact. And you can see it's kind of jumping around, but that's because it's sort of finding the optimal position where it's most vacant on the thing as it moves, and you can change the shape of the object and have it still compute that. We could go into the stroke, and I'll add a little bit. Let's increase, say, the tubes per step to get a little bit more branches there, maybe a little higher. And then it is a little bit noisy when you do things, but it is possible to animate growth with this. If we turn off tube completion, go back to the stroke, and then we could increase the sample density on the stroke. Let's try, say, 10. See if that's enough to need a little bit more than that, maybe about 20. And so now we should get the roses, and is that enough? Yeah, so I got a lot there. And then you can go under the end bounds and just adjust the max clip to do the growth. So you can get your growing that way without the popping on it. You can also use this for spark effects and stuff. So here I've got some objects, and I'll just play. So I can move the objects, and when they're within distance, the strokes will complete and attract and try and fill space to points along the object. And sparks will literally jump off from one object onto the other, if they can, with the effect. I can even move this base object and have everything kind of interact. And it's all sort of automatic. So I could run a little animation of this and see what it's like with a little rendering on it. So it's nice and easy. You can get a lot of really quick spark effects this way. You just have a brush that does it and paint it on your objects. Now, another thing now, not just surface attracting and trying to fill space on the surface and grow into it, we can do it with a volume. And so we do that with a Paint Effects line modifier object, which is this cube I've got around the object here. Now, that'll have these occupation volume attributes. And this is uses kind of a voxel approach. but it's quite efficient. You can have a lot of voxels without it consuming memory because of the way it's set up, and it's fairly fast. So now if I lower the occupation attraction to 0, you just see the normal kind of thing where the plants kind of go through each other and with no rhyme or reason. Now if I make it the attract just a little bit, then they merge, and then if they're intersecting, you know, some of them die where they intersect the other ones because I've got branch termination on here. Now, if we increase the attraction further, it allows the shapes to bend more and distort to try and find the empty regions of space. And so now all the branches can pretty much survive in that. Here's another kind of example of the occupation volume. So I can take this volume modifier and just move it over this paint effects branch, and it's got a very strong kind of attract, so it influences the shape so that it kind of fills the space, and you know, we could kind of scale that out and modify various aspects of that. Here's another example of the same sort of thing. This one I've just flattened one of the volume modifiers, and we can move it around. And if we vary the occupation attraction, if I make it low, then you get kind of curving shapes, right? And as you increase the attraction, you'll get more rigidly, you know, it'll more perfectly kind of distort to fill space. And you can control how much the branches die off towards the tip and the root and stuff by the various attributes there. Okay, here's another example with like a DNA brush, and I can just scale this up if we want, and we'll give it a little thickness. And so you can see now it's sort of filling volume, and so it's sort of like a little simple, you can sort of use it for self-collision in a way of these paint effects elements. They're kind of, all these little DNAs are kind of avoiding each other and filling in the volume of space. So here's another example of how this can be used to shape things. So if I take this occupation volume and just move it off, you'll see what it looks like without it. And it's kind of a jumbled mess on this, and there's a lot of self-intersection. And when you move it, it becomes quite organized and space-filling, a lot more natural to the real shapes. And this models actual plant growth. In a way, this algorithm. It comes from the space occupation algorithm, or space colonization algorithm, sorry. And it's been modified for paint effects so that it prunes instead of creating geometry, so that you have the topology defined by the paint effects already, and you're just kind of working with it. Now another thing we can do is with the volume attract, we can create like a region. It's sort of like food for the plant to grow in, and it wants to colonize those areas. So I've got a mesh here, and that's inside the volume, and it uses the mesh bounds to determine where it wants to fill in. So you have this space-filling growth, and then the branches will just die. It won't get crowded. They'll uniformly go based on the space. And so you can use this with any kind of mesh to fill it. Here's another example of a mesh. I just have a little tree with like a hole in it, and you know, we can move vertices and see the effect of that on the shape of the mesh. Now this is a little bit more complex example. It's still the same thing. So I'm using a head to define the volume, and there's my you know, volume for the line modifier around it, and then these strokes go in and they try and the branches fill the internals of it. You can make it a bit, you can get more complex because you can have inside surfaces as well, so the head isn't hollow. So you can add like a skull, and the branches will avoid the skull and go between it. You have to kind of reverse the normals in the skull usually. It's, the collisions can use the normal if you want, so you can have inside-outside collisions, but you can also do double-sided collisions if you really need that for something. So you've got those options. Now here's a example with a tree house where I've got a volume around that defines an area that I want the tree to grow into, and then a few collision objects like a ground and this tree house. So I can move the actual location of the tree house, and the tree will reconfigure around it to find a solution, and the branches will kind of properly collide with it and grow into it to kind of fill the space around it. And so you can exercise a lot of different design possibilities very quickly without having to remodel. We can do things like this is the region it wants to grow into, right? So I can move this upward, so it just wants to grow up over here or behind or something. And addition, like I can move this collision object, and it will adjust to those things. So you can have the plants interact with your models and sets in a way that you don't have to constantly remodel as you're redoing the set. And so one other thing I want to mention about those is that most of these scenes that I'm showing now, you can get off Duncan's corner on the area. So if you just search for Duncan's corner, you'll find it. And all the models and scenes and some explanation should be there. Now, this last thing I want to show you, when I put in the optimization for Service Pack 1 for this paint effect stuff, so it'd be a lot faster, I wanted to try out a lot of geometry. And so this is just 2 paint effect strokes. One's a vine stroke, and the other is this tree stroke. And so I just created a whole whack of images. I don't know what I was thinking about it. When I created this slideshow, it was my first time using the MacBook slideshow thing, and sound came up automatically. I didn't even want to have sound with it. I was going to talk over it, but it was my shakuhachi lesson that I was sending out to my teacher. Shakuhachi is this end-blown bamboo flute. It's Japanese, and I study with a teacher in New York. And so, and it seemed really appropriate. It was this Zen piece, Mujushin Kyoku, and these images seem to me to be actually very kind of Zen and very Japanesey, but I hadn't realized that when I was doing them. So it was one of those happy accidents. So I'll just play that now. Thank you. Have a great cigarette.